Okay, ladies and gentlemen, I'm going to give you a quick lecture about the atmosphere. Our atmosphere, our air, is predominantly nitrogen. It's about 78% nitrogen, about 21% oxygen. That only leaves about 1% for other things. Those other things could be water vapor, carbon dioxide, argon, and other trace gases. So big thing to know, most of our air is nitrogen. Second biggest component is oxygen. Now, at this point, you should have already done an activity to see how our atmosphere is divided into layers. Here you see an image showing the atmosphere divided into layers. The bottom layer is the troposphere. That's the layer of change, the layer where the weather occurs. We're going to focus most of our discussion today on the troposphere because that's the most important for us in understanding the environment. Above that is the stratosphere. We'll also spend a little time on the stratosphere because that is also important to us, though it doesn't directly affect us as much as the troposphere. Above that's the mesosphere and then the thermosphere. Now in your activity you saw that temperature changes as you go up in the atmosphere. If we start in the troposphere, as we go up, the air gets cooler. Most of you know that. If you go up in elevation, if you go up into the mountains, typically it's cooler. Once you reach a certain point though, the end of the troposphere, called the tropopause, that trend switches. And as you go up in the stratosphere, the temperature actually gets warmer. When you get to the top of the stratosphere, called the stratopause, it reverses again. As you go up in the mesosphere, it gets cooler. And then in the thermosphere, as you go up, it gets warmer. I want to focus on these two layers, and I want to explain why these trends are what they are. So, how does energy get to us on Earth anyway? Most of our energy comes from the sun in the form of electromagnetic radiation, in the form of light. Our atmosphere is largely transparent to light, so as those rays come in, most of them come through until they get to the ground. When they hit the ground, some of them are reflected, but most of them are absorbed. So sunlight warms up the Earth. So here the Earth is warm because of the sun. So that heats the air above it. So the air right above the ground tends to be warmer than the air above. Now, as that air is heated, it expands. When hot air expands, it's less dense, so it rises. And as it rises, it cools. So the reason that the air near the Earth is warmer is because the ground is warm. That warms the air. That hot air rises and it cools. This is going to set up something called convection currents. Convection currents are going to be hugely important for us to understand both weather and climate. When we reach the tropopause, the trend switches, and I want to talk about why the trend switches. In the stratosphere, there is a layer called the ozone layer. Now, ozone is a form of oxygen. Instead of being O2, it's O3. As electromagnetic waves are coming in from the sun, the ultraviolet rays, which are higher energy rays, those that give you sunburn, those that can be harmful to things below, are absorbed both by oxygen and by ozone. When the oxygen absorbs the ultraviolet rays, it forms ozone. The ozone itself also absorbs some of those ultraviolet rays. So, as they absorb the rays, that causes them to heat up. Just like the ground absorbs the light, that heats up the ground, the ozone absorbs the ultraviolet rays, that heats up the ozone. So this layer is also hot. So that makes the surrounding close to it hotter than the surrounding below it. So this is hot. So here, as this hot air rises, it cools, but as it gets closer to the ozone, that warms it back up because it's absorbing the ultraviolet rays. Now, this is important for us to understand because that ozone protects us from those ultraviolet rays and some of the harmful effects. So let me summarize. In the troposphere, the ground is warm, that heats the air above. The hot air rises and it cools. As it cools, it sinks back down. So the bottom is warmer, the top is cooler. As you go up a mountain, the temperature generally goes down. In the stratosphere, the pattern is reversed because the ozone layer is warmed by the ultraviolet rays, so the warming above makes this part warmer and the part below cooler.